This project analyzes the correlation and relationship between 30 countries' total carbon dioxide emissions and their temperatures. Climate change refers to a long-term change in climate patterns because of greenhouse gas emissions. Greenhouse gases trap heat in the Earth's atmosphere and eventually result in extreme temperatures, natural disasters, rising sea levels, poor air quality, decreased amount of clean water, extinction, and increased spread of diseases. Carbon dioxide is a greenhouse gas that causes climate change and therefore increases the temperature. Researchers from the University of New South Wales revealed that increased temperatures was the first sign of climate change, highlighting the prevalent correlation between a region's carbon dioxide emissions and its temperatures. Research on this topic is important for society because humans only have one planet, and if it is destroyed, humans will eventually go extinct. If action is not taken, many people will get sick, lose their jobs, lose their homes, prices will increase, the weather will become unbearable, and eventually, humans will struggle to survive. NASA research has also shown that the effects of climate change are irreversible at one point. Researching this topic has educated current generations about what causes climate change and how to take action to prevent it. However, much more research and advocating is required because many large corporates continue to ruin the planet. Most individuals are not educated or convinced about living a sustainable lifestyle, and millions of people still do not believe in climate change. Further research is also needed so that countries and large corporates know the necessary steps they need to take to prevent and reduce the effects of climate change. The dairy farming industry, the beef industry, cruise lines, fast fashion brands, Amazon, the non-renewable energy industry, plastic water bottle companies, the agricultural industry, and the residential sector are some of the biggest contributors to climate change and have the most power to make change, so they would really benefit from this data. They would also have disadvantages if they took data seriously because they would be losing money. However, losing money is very worth it if it means saving the planet. In addition, motivational speakers, politicians, and celebrities are able to advocate for change, so they would find this data valuable as well. But since climate change applies to everyone, every single person would find this data valuable. The independent variable is the total carbon dioxide emissions per country. The first dependent variable is the average temperature per country between 1960 to 1990 in degrees Celsius, and the dependent variable is the highest recorded temperature per country in degrees Celsius. The total carbon dioxide emissions per country is independent of the temperature, and the temperature is dependent on carbon dioxide emissions. These variables would have a relationship because carbon dioxide is a greenhouse gas that has been proven to be a contributing factor to climate change. Here is a histogram of the average temperature per country between 1960 to 1990. The mean for this data is 15.59 degrees Celsius. The median is 16.03 degrees Celsius, and the standard deviation is 8.76. The distribution for the histogram is bimodal because there are two groups with different attributes. The frequency for negative 10 to 5 degrees Celsius is much lower compared to the frequency for 6 to 30 degrees Celsius. These results make sense because the average temperature varies depending on a country's geographic location. Here is the histogram for the highest recorded temperature per country. The mean for this data is 46.76 degrees Celsius, the median is 48.1 degrees Celsius, and the standard deviation is 5.73. Once again, the mean and median are similar and there are no outliers. The standard deviation for the highest temperature is smaller because the data is not as spread out. Both standard deviations are relatively large due to variance in temperature. The highest temperature has a lower standard deviation because all of the temperatures are quite high. The distribution for the histogram of the highest temperature is left skewed because the frequency increases on the right side of the graph. These results make sense because climate change continues to rise as carbon dioxide emissions rise. According to NASA, the planet's average surface temperature has risen about 1.18 degrees Celsius since the late 19th century. A change driven largely by increased carbon dioxide emissions into the atmosphere and other human activities. Most of the warming occurred in the past 40 years, with the 7 most recent years being the warmest. The years 2016 and 2020 are tied for the warmest year on record. NASA's research shows why temperatures are so high in the histogram of the highest temperature. The role that this data has in the investigation is that the double Y variable shows how much higher temperatures have risen in comparison to the average temperature a few decades ago. The impact this data may have is to encourage countries to reduce their carbon dioxide emissions to prevent climate change. The limitation in this data is that the histogram of the highest temperature has some extraordinary temperatures above 55 degrees Celsius. So the histogram is not completely left skewed. However, this gives the world a glance as what is to come if carbon dioxide emissions are not reduced. Here is a combined box and whisker plot with both stratas. As you can see, there are no outliers. This makes sense because the temperature on Earth stays between a specific range so that organisms can survive. Here's a scatter plot graph. The R value for the average temperature is negative 0.2677, and the R value for the highest temperature is 0.2074. The correlation coefficient for the average temperature shows a weak positive correlation. Similarly, the correlation coefficient for the highest temperature shows a weak positive correlation. I can conclude that the total carbon dioxide emissions from 2015 do not affect the average temperature in 1960 to 1990. I can also conclude that the total carbon dioxide emissions from 2015 somewhat correlate with the highest temperature in my graphs. This is because the graphs do not take distance from the equator into effect. The website I used for carbon dioxide emissions had a reliable source from an American organization, making the information credible. I could not find one resource that listed the highest temperature recorded for every country, so I had to use multiple sources. Using multiple sources for the highest temperature per country leaves more room for error. I had to assume that the information from every website was accurate. There is also a chance that there is response bias. Response bias is a bias that occurs when participants in a survey deliberately give false or misleading answers. Countries may have put out false information by lowering their carbon dioxide emissions from what they actually are. Some countries may have lowered their carbon dioxide emissions so that they do not lose respect for being a big contributor to climate change. Another limiting factor includes extraneous variables such as geographical location. A country's geographical location plays a big role in temperatures, so it has an effect on both the average and the highest temperatures. As an effect, there was not a strong linear correlation between the carbon dioxide emissions and temperature, when in reality, it is proven that carbon dioxide causes climate change, which results in changing temperatures. The World Meteorological Organization states that at the current rate of increase in greenhouse gas concentrations, we will see a temperature increase by the end of this century far in excess of the Paris Agreement targets of 1.5 to 2 degrees Celsius above pre-industrial levels, showing that carbon dioxide emissions do in fact have a correlation with the temperature.